Welcome to this session on 3D Gaussian splatting. It will be fantastic. We are going to attack hands-on how to go from a set of images, transform that as a 3D Gaussian splatting experience, and then move on to creating point clouds and also renderings that we can use outside of what we're going to target with 3D Gaussian splatting hands-on. So again, super excited to host this little event. The previous session, we targeted point cloud vectorization, 3D modeling, also semantic segmentation with KP-Conv and deep learning architecture. And the latest one was with Gaetano, and it was depth image to 3D, so single image to 3D datasets. And here it's something a bit different with 3D Gaussian splatting. So I waited a lot to, let's say, make something around it, because it's going super fast, all this technology. So it's good to have at least a little backlog, right, on things. Especially today, if you push things in production, we don't have as much vision as before. When we were pushing something in production, we had, I don't know, 5 years of research or 10 years, and we know the limits and the advantages. Here, there is a new tech, and it's boom, ingested into production without too much backlog. So it can be a bit tricky. So I always make sure that I filter out the noise so that you know what is super useful. And Gaussian splatting definitely has its in and out. It's super active currently. There will be new evolution. I will speak about something that you can directly use for yourself. The only limit, if you want to replicate everything that I will show you, is to have a CUDA-enabled graphic card. So basically an NVIDIA, I would say 2060 plus, right? I'm with a 3090 RTX, so that's a good one, especially if you're in the process of building your own setup and you want to test things locally, which is usually much nicer to develop quickly. I would recommend this 3090 RTX or 4090 RTX. They are super expensive, but you have a lot of VRAM, which is super useful whenever you need to fit a lot in the memory. For example, I have 24 gigabytes of VRAM, which is more than enough to make local tests without having a lot of GPUs, which is good. All right, so yeah, as part of the deliverable, the live session recording, hopefully this works. I'm not entirely sure again. If it's not the case, I will remake a session and I will post a post-process video, so it will just be me redoing that, but without this live element of things. And then after, I will share the dataset links. I will put that everything on Google Drive or some kind of drive. And the resource curation, if you want me to explore some kind of article, I will show you pinpoint some that you already know. But there are some other coming up which are super interesting. And I will share also cheat sheets to make sure that you can have that standalone and work efficiently. So the mission today, it's pretty simple. We'll start with an image set. We can do that from a video as well. We'll go through this step of creating 3D Gaussian splats, okay? And then afterwards, I want to show you two kind of deliverables from that. The first one being a 3D point clouds, and the second one being 3D renderings. Of course, the integration, especially for VFX, you are used to work with a lot of rendering engine or things like this and pipelines. So the integration of Gaussian Splat is already very heavy there, but I will not have time, I think, to touch there, maybe for the session, just so that you know. The main concept that we will approach at this stage, there's the following. It's pretty, like I condensed down to what is really essential. So the first concept, which is nice to have an idea about, is photogrammetry, but only a portion of photogrammetry, which is called structure from motion. And I will speak a bit about that a bit later. Then after, it's all about Gaussian Splat. What is that word about? It's actually something which is not at all new. It's more than 50 years old. And it's something that was used heavily, but without this training process. And then after, we have 3D point clouds, which is something that I'm super attached to, and I will speak a bit about why I'm attached to that. So the first concept being structure for motion, and this is apart from photogrammetry. How it works, it's very simple. We'll take the images and we'll go through the 4 steps that I checked here. So the first one being feature extraction. for each image, we'll find some points of interest with some algorithm, like sift or orb or surf extraction algorithm that will take points that should be key points in images so that we can tie them together in a later steps. So that's the first thing. After that, we go through image matching. This is not always done, but usually you want to group images based on some metadata that you have or some kind of vocabulary tree that you can create. And this is the second step that is usually done. After that, we have the feature matching step. So we take the feature extracted and we match the features in order to know exactly for an element in the scene, which images has this element in the scene. So this allows us to then go on to structure for motion and basically determining the pose of each image, so the location in the world space. Okay, and this is super important for any photogrammetric process. Whenever we really need to be very precise about what we need to reconstruct, this step is essential. And after that, we go through dense matching, so matching each pixel in each image. But this is where there is a first difference between photogrammetry and Gaussian splatting workflow. Here, we will not go through dense matching. We avoid that. This is time consuming or computing wise very expensive. So we skip that. We stop at the structure for motion sparse point cloud, they say, and that's the output of these steps. And this will be the input of the next step. So the use backend that you will find in the research community or in softwares is usually CallMap. It's a very good one, but if you want to push a bit behind, like the processing to a certain extent, like scale-wise, if you want to process more images or skip this alignment phase or structure for motion phase, I would recommend two solutions. The first one being Mushroom, which is open source as well from Alice Vision. And the second one being really TCapture. It's not open source, but they changed their licensing system. And now if you make, I think, less than $1 million in revenue, you can have a free license to use their software, which is amazing. Reality capture is really, really great. Especially it's super fast because the guys behind, they are very good mathematicians and they do matrix inversion things to speed up a lot the alignment process, and this is super, super nice. Outside of that, you have other solution, right? I'm not affiliated to any of that, just a reminder. But yeah, you have other solution like Metashape or context capture that is now called iTwin. I don't remember, but they changed their branding from Bentley Systems. And you have other solutions that are paid solution, but equally, if not better, for some. Just that you need to share some coins to get access to that. So if you want to switch to another backend, this is feasible. Okay, so we have our sparse point cloud, and then we go onto this Gaussian splatting. And I just need to be a bit bland or a bit simple on that. It's just a matter of rasterizing, right? Going from this 3D data set and projecting that onto our screen. So it's a rasterization technique. And instead of in VFX, or usually we will rasterize meshes with triangles, here the single unit is a Gaussian splat. And basically it has a position, so where it's located, XYZ, a covariance, how it's stretched or scaled, the color, and the alpha channel. So here you have the border for simplicity, but it's not like this when you display that. And basically, when you have a lot of Gaussian splat, you have this element that plays very well together. Okay, so what is the big difference by just a standard rasterization technique is that we couple that with stochastic gradient descent. So it's similar to what we have in neural networks training phase, but we don't have the several layers. It's just one pass. We look at the gradients and then we compute the loss. And depending on that, we will back project and adjust what we have. So we first rasterize the Gaussian to an image with this differentiable Gaussian rasterizer. The D stands for differentiable. This is a bit fancy word to say that we want to have a bidirectional communication, meaning we go from 3D to 2D and we keep the link to work onto the 3D space so that we can readjust. If the novel view synthesis is not good, then we readjust a bit the parameters. Then the second step is we compute the loss. which is the difference between the rasterized image and the ground truth image that we shot. And based on that, we adjust the Gaussian parameter. So we minimize the loss. That's all it is, except there is an extra step where we will densify or prune the data set, meaning if we want to have sharper geometries or more precise, we will densify. So we split a Gaussian and add another node, for example. Or pruning, we delete some when they are really out of bounds or out of the parameters that we fixed. Hopefully this is clear. I turned my head around to make that as simple as possible as a first layer, because I think it's essentially not that complex. What is a bit more complex is what is happening under the hood, but this is going so quickly that it's good to have the understanding of what Gaussian splatting stands for, and afterwards we are able to deal with the evolution of things. Okay, the third point is 3D point cloud. So 3D point cloud, it's very simple. I really like this way to represent data sets. You basically have a geometry, so X, Y, Z, and a lot of features, F1 to Fn, right? So these features could be color, but in the case of Gaussian splatting, we'll have features as spherical harmonics. We'll have a lot of specific features that will help the how to rasterize, how to display the point cloud. Essentially, it's a bit more complex, but this is how it spans out, which means that you can actually derive from the Gaussian splatting a point cloud, which will be denser than the structure for motion that you have, right? So this is something super interesting, because if you were to take the classical processing line with photogrammetry, you will have to go through dense matching. Here, you don't have to go through dense matching, you go through Gaussian splatting. And the other possibilities is to go with NERF, which is very similar to Gaussian splatting, except you are not as efficient for real-time rendering. You cannot process as many images. You go into some kind of struggles there. But things are also going pretty fast there. So let's see how both compare in the short and the long run. I'm stopping a bit to see if there is any question at this stage. Alice, can we have some resources for beginners? Yes, so I think this specific live will act as a first step towards that. And then after we'll share some article that I wrote or some research article. If I have time, I can also take some time to share how I read a research article, how to go through the various things, what is important to read, not to lose time because it can be quite complex. All right, so this is the phase overview that I will do. And I wanted to have a full standalone version because you have some software, some cloud solution that will allow you to do that, and you have some code solution as well. So with Python, that allows you to inject that within your pipelines. Here, I will illustrate everything with the post-shot software, which is open for now in beta. And hopefully on the next session, I can move on to the Python stages and also how we post-process the output, the point cloud. I remember that I had a question about how to georeference this Gaussian splatting and such. I think this will be also very interesting. What is the main advantage of Gaussian splatting over SFM? So basically, Gaussian splatting is an extent from SFM. You take the SFM node, and then after you train your Gaussian splatting, and you will have a denser point cloud. So if you're interested in the geometry, you have something much denser. If you are interested in the real-time aspect of things and rendering possibilities, then it extends far behind SFM because you have all these Gaussian splats, interactive scenes. Is this good for building neighborhood or bigger? Photogrammetry is very good to build neighborhood or bigger because you get here the full scene and you have something that is well established since more than 20, 30 years. So you have a really big backlog. So there are established solutions there. I can speak on that a bit later. With Gaussian splatting, it depends on how much time and how much compute power you have. But I did some training, for example, where I inject 5-minute videos. And it will take, if I go to 30K steps, it will take at least 12 hours to train. And at the end, it's not super stable, so you can have crashes and then you cannot export your data. So still, it's very close to research. This is what I said. Going into production with that, just limited to small experiments, some MVPs, things like this. All right, let's get into the stages 1, 2, 3. So installing post-shot software, downloading the data sets, importing the images, launching the training, and we will check the result and generate a rendering and export the point cloud. So just to show you, so this is a very good paper that I will share by a very good team. So this is the jawset.com. This is where you will be able to download post-shot. You see system requirement, Windows 10 or later, NVIDIA GPU RTX 2060, or a Quadro T400. Okay, you download the software, and after post-shot, you just have to launch your software. You have regular update. I will not update it for now. Okay, he opens the thing that I closed. So let me start from scratch so that I can show everything and fall into the live effects of having bugs and things like this. This is where I take risks. So basically, you drop your files. This is very simple. This is how it looks like, this post-shot software. And on the back end, you have enough possibilities and Gaussian splatting. So what I will do is first take some images. So there's images. I wanted to try something a bit dangerous. I took some images. When was it? I think it was in 2018 or so. I went to Norway, and there is this beautiful Vigelund. I don't know if I pronounced that correctly, which is a museum. And there you have fantastic, as you can see. So let me open. They have this little handmade, okay, it opened this way, so let me put it here. This little handmade reconstruction. And I was thinking, oh, that would be fabulous to recreate stuff. So back in the day, I was heavy onto photogrammetry, and I did a lot of reconstruction with that. But with photogrammetry, you will have a lot of problem to reconstruct this little, how is it called, ropes, I guess. Onto the boat, for example. And what I like very much is on the reconstruction. Okay, so you have walls, but this is, I think, a theodolite. So to measure angles and distances, this is something not new for surveyors, but this is very nice that they put that into this little reconstruction. So this is why I chose this subject. So what I do is I take all the images and I just drag and drop that. Now you have now you have this little window that open. I hope you can see that on the stream. Else I need to find a way to zoom, but I don't have a direct way to zoom in. Maybe if I do that, no. But basically you have some kind of parameter to set. So the max image count, this is very important if you want to shorten your time of computation. The max image size as well. This is the max width of your image. In this case, image selection, you can use all images or base images the same. I will use the 27 one. And how many features? This is the feature extraction you want to have. So 8,000, that's a good number. If you go below 4,000, you have large chances that it will fail. And the camera poses, you can compute them from the images. Now for the radiance field profile, you see that you have a lot of stuff. So you can do Gaussian splatting on NURV. You have various ways that it was designed. And with Splat, you don't need to adjust anything. With NURV, you need to say how big is your scene and how precise you want to be. Basically, for super simple scene, you put NURV S, and for massive scenes, when I say massive, it's like 300 images. And it's very, very little compared to huge photogrammetric processes, for example. But if you want also very high precision, you will take the XXL or XL. But beware, because the time to train there are very, very high. So let's keep it with Splat, Splat density 1. If you move higher, you will have more densification effect, which is nice. But again, computing-wise, it's a bit bigger. For the training, I would recommend to go at least 50K steps, but it takes longer. So for the demo, I will put it to 10K step. I don't know how long it will take, maybe 5 to 10 minutes. So we will check out other things in the meantime. So I import. And you see that it do the camera tracking steps. So here it goes very fast because I have 27 images. And here it shows how many features we have extracted from the images and how many points are created. So he's still in the camera tracking phase, which means he's creating the structure for motion point cloud. And once this is done, he picks that up as a seed for the Gaussian splatting training. So as you can see, he's training in real time. So you have here the camera poses, and here you have the scene that is being refined more and more and more at each step. So that this phase, we are at 1.5K steps, so 1,500. And we took 30 seconds to get there. It will take us approximately 2 minutes 30 to get to the full scene. But what is super nice is that already there, you can adjust your scene, you can see what you have, which is fantastic, right? So you see, it's not like voodoo science. It's really something that you can get quickly working on your end if you just have this small prerequisite being Windows and the GPU side of things. If not, you have cloud solutions. I'm not a fan of cloud solution yet because you cannot adjust too much how many images you want to have, how many videos you want to have. Here, what is also nice is that you can drop like 4 or 5 different videos and a lot of images, and it will pick up the pace, or you can also inject metadata. So let me show you. On the right side on the scene, you have the image set, and you see that you can select some images and you have some action where you can import camera poses, use image camera to display or export images. So if I take the image 7 and I say use image camera, it will go onto the position to see and remove it to see where we are on the Gaussian splat, right? Very cool. So now what can I show you? On the left side, you have the ability for now just to navigate until the training step is stopped. You have the possibility to pause the training and resume the training at any stage, which is also a very cool feature because it makes it very interactive and you don't have to wait so much. And I know nowadays it's very hard for us to wait. We're used to everything instantly. So yeah. Okay, so something that I want to show you is the sparse point cloud from Structure for Motion. If I click there, it will remove the current radiance field, and you can see the sparse point cloud. This is the base that is taken to then have the Gaussian splat. And for the Gaussian splat, I will wait for it to finish to adjust the quality of that, but it will be finished pretty soon. So at this stage, I don't know if you have any question. It's pretty straightforward, right? I will still check if there are any questions. No, I think it's good. So if I zoom in already at, you see it's a bit artistic almost. It's really cool. There's Gaussian's effect. It's really different from what you may be used to if you played with point clouds before. You have some ways to adjust how the borders to one another behave. Here, it's really much smoother for the visual aspects of things, and also the capability to be real-time and efficient. This is really nice, from my opinion. So we're almost at the end. I couldn't understand how did you create data. So basically, I don't have my phone here, but I think I have a camera. But yeah, you just need a camera. You take some pictures, and this is what you will get. Other kinds of I don't know, other kinds of video that you can get up and running. So what is that? Is that an iteration? So this is, for example, this is a rendering of my office, a bit messy one, which I did with 30K iteration. And this is just shooting a video for 30 seconds, and you get that as a result. V2. I don't know if I have other things. A garden. Yeah, this is the kind of video that you can shoot. So there are some principles, right, that are the same as photogrammetric principle. Any points that you want to have reconstructed needs to be seen from at least 2 images. And when you shoot a video, basically what post-shot will do, or what you need to do, is to sample your video and extract frames at any speed you want, like 1 frame every second or 5 frames every second. And then with post-shot, you have the ability to actually let him decide based on the quality, if he detects some blurry effects or things like this, which frame he will use. I see a question that is very interesting about 360 camera. This is feasible. You can use that. I'm actually putting in place a full workflow that will go through one of the course line with 3D reconstruction with 360 cameras. It works. It's very nice because you don't need to have so much, to be so much, how do you say, to check so much how you acquire the data on site. You can be a bit more random, how you walk, how you design your path. But you still need to split basically your lenses into at least 2 lenses, because else you have too much deformation. The models that are underlying, usually you will use brown or fisheye way to model the camera perspectives or the lens perspective. And this is something that is much, or give much better results if you at least split into 2 lenses, because 360 camera, they have at least 2 lenses. Like if you take the Insta, the new one, X4, this will be something that is perfectly feasible and gives super nice results. Now for the path, let me open one of the most beautiful app. Paint. No, I'm joking. So if a scene is like this, very simple. No, it doesn't work this way. If the scene is like this and you have an object in the center, the way to acquire the data is you go around it. So this is very simple because you have a lot of overlap between your images and your data. If you want to reconstruct the walls here, it's the same thing, right? So the camera here are oriented this way. It's the same thing, except you will go along the walls like this and shoot every time the opposite direction, right? And here you will have a lot of overlap as well. Cases where you have large fields, usually, or with 360 camera, the path that I recommend is this one. Imagine that is an outside and that's just the extent. You will do this exactly like with a drone. You do this. We'll go until the end, choke, 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 and this way as well. And you orient the camera maybe down, like not a pure nadir position, because you will not have so much understanding of the 3D geometries. You orient it maybe 15 degrees, okay, oblique, and it will make work with you. So still, this is if you don't have a 360 camera. Sorry, if you have a 360 camera, you can do that as a post-processing step. So this is how you acquire the data. This was really short, but basically you see that it's not too complicated. You just need a camera, so a passive sensor, no LiDAR at this stage. All right, so the training is done, and this is what you have after 10K steps. So it took more or less 5 minutes, right? It's not linear. So if I were to have not 27 images, but 54, it will not take double time, but a bit more. It's really not linear at the time of computation. So this is how it looks. You can see that you have some haze effects. So there will be some cleaning involved if you really want to use it for rendering something nice. But what I really like, as you can see, is you have information for all the ropes. And this is something super hard to do. You can here grasp somehow each ropes independently. Now we don't have any metric information. It's something that is nice to look for, but we will need to scale it, to put it somewhere, to constrain it if you want to use it for metric application. This is really something important to have in mind. Before going there, because I see time flies. Let me show you what you can adjust here on the radiance field itself. So this is the training where I say to stop at the second step. If I were to continue the training, I could add more, but I will not do that at this stage. Now you can edit or play on the rendering side of things. Something I like to show is, for example, the depth. You can show the depth as grayscale. I will remove the point and invert the depth to see a bit more. And you see you have very nice information about the depth of the scene. And there's a small perks of having radiance field as a way to represent data. You really have a lot of hand to play with lighting, reflection, texture, things like this, which you don't have so much capabilities with photogrammetry, especially for scenes where you have varying light condition. This is where the differentiable Gaussian rasterization is super effective, because it allows you to get this sense of, depending on the viewpoint, you will adjust the reflection. So if you shoot at a mirror, or my sunglasses, for example, which are very bad, but you have a lot of reflection, this is something that will be super or not possible with photogrammetry. With Gaussian splatting, you may not get the geometry, but you will get the reflection capabilities. Super cool. Now, let me show you something. As far as the parameter of the splats, you have splat scales here. So if I reduce that, you see a bit more what we are talking about when we say Gaussian splatting. This is really a point with this covariance matrix that will extend it, right? Give a certain orientation and an alpha value. And if you go very high, you have a lot of haze effect. But you see that there is a fine interval. Usually it's around 1, because we train with 1, where you have something that makes sense. This is what I wanted to show you with radiance field. You have the ability to edit it, transform it, scale it, crop it. There's things you can do here. It's the software is progressing, so I will not dive too much there. But what I can show you is how you can maybe render some scene within post-shot. So the first thing you need to do is create a camera. Okay, so here I put a stupid position, but that's okay. And then you see you have a line here, which is basically each unit, 1, 2, 3, 4, 5, is a frame. And whenever I will export, I will say how many frames per second I want to have. So if I have 30 frames per second, I want 10 seconds, I will say 300 maximum. And now I would say this could be my first position, for example. You will see how I do. And I create a key. And then I go at 1 second, so 30 frames. I will move at another position. Like, okay, I have a little haze effect for some reason. Yeah, okay, I have one which is annoying. I could go there, and because I'm a bit skewed, I could adjust this rotation angle here. But I'm at the viewport camera, sorry. So we need to do it. So the first one I took it here is very bad, so I will redo it. I will adjust the rotation, and I create my key. Then I move to 30 seconds. I go there, I rotate a bit to be a bit better, and I create my key. And you can continue like this. For example, if you want to zoom in, there's little guys here. This one that is holding the box. I forgot to go there. Let me zoom in and create a key. And I will do a last one, maybe this way. Okay, and I will create a key. And now you have an interpolation that is done between the keys, which is usually bilinear, I guess. And you see, this is the kind of rendering that you will create from your scene. So you have a lot of free hand to do that. And the only thing that you have to do is prepare your codec and export as an AVI or MP4, depending on what you have on your computer. That's it for the rendering side of things. Now, what if we want to use that as the data itself, the geometry? We can export a point cloud. So everything is full. Let me go on to webinar. So this is the one I just exported in case I had a failure, Begelund live.ply. And I save. So it's a PLY file, so very standard, which is super nice. And now what I do is I will open another software. Cloud Compare because it's also very fun and easy to use. If you don't know this software yet, this is called cloudcompare.org. This is where you can get the software. It's also an open source initiative. You can donate to the team. It was created as part of a PhD thesis. So very cool software. In here, I will then take the data webinar Vigelund live, and I will drag and drop it. So at this stage, sorry. At this stage, sorry, you have the ability to load some kind of features, as I mentioned, especially X, Y, Z, and also the normals. But there are a lot of features. So if I were to click here, you see my PLY, this is how many features it has. So there is a way to import that automatically in Cloud Compare without having to put that manually, adding Scala field. I will not show that today, but it's pretty straightforward. I show that as part of a course line in the 3D Reconstructor course, for example. I would just want to have red, green, and blue. So these are these, not rotation, DC, DC, DC1, and DC2. And then I will put apply all, and you will see this is our point cloud. So as you can see, it's not scaled, it's not well oriented, but these are things that you can do within Cloud Compare, except here, any editing that I do, because I did not load all my features, when I will export, I will lose information which will make it not compatible with web viewers, for example. So normally I should import a different way. This is just to show you what kind of data you have. So let me zoom in and look at the data. So you see that it's much denser than a sparse point cloud, and that you have points here, which is super, super cool. And here you get onto classical ways to process the data. If you had a scale, so let's say the scale of this boat is 40 centimeter. So basically, you could scale your boat to have exactly that. You have ways to scale, so you can scale just by applying a factor, right? So if you want just a factor, you measure. I will take the front of the boat and the back of the boat. So here it says that it's 82 centimeters, which may actually well be the case, but that will be pure luck. It's not at all based on the camera poses estimation, because we had no clue or no scale information. So we cannot extract that directly. But if we were to say this is 1 meter, then we will have to adjust the scale to push that to 1 meter. So let me do some computation that I'm not proud of. So please don't hate me for that. So 1.4, same scale for all dimension, keep and tight in place, and we don't have a global shift, so I can do that. And now, if I were to retake, if I were to retake the distance, oh, I lost my boat. It was, I think, between that and that. We have 1.17 meters, so I'm not at 1 meter, but you see that I scaled. Then for the rotation, what I would advise is you go onto a top view by clicking here, you take your boat, and then you apply a rotation. You don't do a translation, you just do a rotation. So we'll do that. Yeah, I will do a rotation like this, and I will go onto a top view somehow. This is fine to me. And now you see that you have your data set that is oriented. As you can see, it's a large box because you have a lot of outliers. If you were to filter that out, it's feasible, but you will lose in the splatting quality. Still, it will be nice in that case if you just want the boat, right? You can just cut out your boat. This is just very simple tools to use. And in here, I will also, I don't want what is above, and there's little floating elements, which are little splat as well. I cut, I delete what is outside, and this would be my little reconstruction of the boat. We loaded the RGB information. You see that it's overexposed. This is normal because it's used for Gaussian splatting, but this is basically what you have as far as the geometry goes. So georeferencing is pretty standard. If you have targets, for example, you can push that and scale that automatically. I did not do that, but this is how you could do that. And I think at this stage, what do I have left to show? Yeah, you can create web apps. So here, this is a specific web app, but I will show you maybe in another session. Rendering projects and point clouds, you have ways to clean that and such. And I just want to show you how it looks like after converting as a point cloud. Did I delete my point cloud viewer? Yeah, it looks like I deleted it. Yes. So I had developed a small point cloud viewer, but it will be for next time. It's okay. Now what I can do is maybe show you. Okay, it's running. Perfect. What experiences splatting? Okay, this one is not working. Splatting, maybe this one. Yeah, this one is working. And this is the web experience that you can get. And here, for example, yeah, this is the office. And this is the kind of, so it's still rendering in real time. So this is the kind of thing that you can share on the web. Here, it's just a local server that I created. This is how then after cleaning everything, you re-inject it, and then you have your local thing. So here the problem is I did not adjust how planar it is, but still you see where I'm going with that. So you can very quickly, so here it's within 30 minutes or such, create your data and then have the pipeline that will process that and push that to the web, which gives more freedom about how you want to share data sets. Visually, you can add, of course, some kind of labels. You can have some kind of experience around that. So very cool for getting a much nicer real-time results in that sort of things. So now, if I get back and then after I will check the questions, of course, I just want, before I forget, to share all the materials that you have. The introduction is done, the live session is done, and yeah, maybe some words about what animate me since some years. So I've been heavily involved into teaching and sharing knowledge as much as possible through various channels, whether at the university or for professionals or both. What I really stands for is transforming this knowledge into applied knowledge, because it's very easy to get lost into the amount of information. So I make sure that I share that in a way that you can just apply it so that it becomes a skill. I try to filter out what is signal and what is noise. So usually that means that I will go deeper onto subjects and not float around for getting more views or whatever. This is something that I'm really attached to, especially today, to construct something that is relevant for years. Part of the learning phase, this is somewhere where I've been active for very long, either at the university teaching up to the masters or having PhD students, or at various companies where I advise or I direct teams of 20 researchers or such. And the last thing I'm very attached to is why I do this kind of event is to have the possibility to interact. So for now, it's mostly through the web or locally in the south of France, in Belgium, in Netherlands. But I intend to create some kind of yearly event where we can group everyone and maybe have a presentation panel on topics that are of interest. So if you're interested into growing, I specialize everything around 3D and AI. And my advice will be to start, if you go on the website learngeodata.eu, to start with the fundamentals. I have an email course, which is free. And every day for 7 days, you have some PDF that dives onto a topic. Then after that, you have the Creator operating system. So this is part of it, for example, Gaussian Splatting to generate data. And I'm working on generative AI, which will go also along these lines. Now, after that, if you are more looking to establish a product, a solution end-to-end, right, and automate, this is what I will call engineering, 3D engineer operating systems. And after, if you are more onto the cutting edge side of things and you are heavy onto coding and you want to make sure to take the latest stuff and you know, just unwrap it and play with it, this is the AI researcher OS. And what I'm working on is creating this innovation branch where I can accompany you from idea to product to market fit to making sure you protect your IP with patents, with papers. This is very important today, so that you can first be a creator, someone that innovates, and second, maybe make some kind of business around it or make your passion something that you can live off. For the knowledge side of things, I open a lot more stuff this year because I had a bit more time to do that. It's of course not easy because usually you need to work on things that I was not used to, like production value, how to set up, you know, the gears, whatever. I try to keep most of my time onto coding and creating content and exploring and making sure things are relevant. And then if you really are serious about and identify what you need to develop as skills, then I would advise to go onto the production systems with the courses, or to reach out to me if you have a clear idea about something and we can establish a roadmap, or books, but more on that later, that are coming up this year. Two things very pragmatic. You have the 3D community. We share the link right after. We reorganized it with Jean-Jacques, where basically the idea is to grow together, especially with R&D efforts. If you have problems, we have people from a lot of background, as you see in the chat, like Julien from Airbus, or we have people from Netflix, from Google, from Meta that are part of the community. But we have also smaller companies, small startups that really want to push the boundaries, and basically it allows to grow much quicker. And the course track. So if you are more onto Python, you have 3D Python, detector, and deep learning. If you are more on the rest, you have other things, but I will pass there. So this is the link for the 3D course library, and I think I will stop here sharing the tracks that I established to help you as much as possible, and I will get back onto the live and check out all the questions. All right. So I hope I was clear on most of the thing, and I need to go a bit above the link, the post shot. It's okay. Are the rope just in the visual or also in the point cloud? So you saw, Marco, that is also in the point cloud. I can actually show the comments. It is a nice feature. So is it possible to import this data as a mesh, for example? So this is what we saw. You can export the point cloud, but if you want to go through the meshing phase, then you need to have this extra phase of turning the point cloud to a mesh. But this is feasible. But actually, Alejandro, you answered for me, so thank you. And you showcase the methods to do that. Very cool. So LinkedIn user, Anonymous, recommendation from a video of street section. Given that cannot go around the building, yet take image shot different. Will the stitching be still? We'll see. Yes, for a street section, basically, I'm the street, okay, from a top view, you go there and then you go there. And you try to orient the camera onto the same direction, else you will have lighting problematic. So it's pretty standard. Doing that, you will get the reconstruction that you want. But I always advise, if you want to create something that is accurate, meaning going down to 2 centimeter level. Sorry for our fellows in the States. I have troubles going from the metric system to your system. Therefore, if you want to go below 2 centimeter, this is perfectly feasible. Just make sure to calibrate your camera, and you have some procedure to do that. Just reach out if you need some help, or reach out the community. There are resources there to do that. Can you mention the point cloud viewer software again? So this is Cloud Compare. Okay. Very cool. You have other ways to visualize it, and if you code with Python, you have also some libraries that allows you to build some kind of interactive viewer within, but you will still be limited here at around 200 million points. you will get laggy effects. So usually we have tiling strategies or breaking down the point clouds if you are larger scene. Oh, but Anthony, you answered for me. Sorry, I go too quick. Okay, is it possible to align the images in Agisoft with control points or scale bar, then import? Yeah, it's perfectly feasible. And this is something that I would recommend. If your pose estimation is already constrained, right? Or if you have georeference image and such, then your splat will be also georeference. What I always advise is splitting up what you use as control point after the adjustment, so basically just a rigid transformation, and what you use within to also just some kind of deformation. You need both, and you need also control point to assess your accuracy of your construction. Can we get the presentation in a PDF? Yes, if that's useful for you. So this is through LinkedIn. I don't have your mail address or anything. So if you want me to send that, I will not have time to go through each individual address. So what I propose is, if you're not part of the academy, you just subscribe to the, I can show, I think, yeah. So you just go there, learngeodata.eu, and you go on to email course upright, and you just type your email and you say, okay. I don't spam. Usually I send one newsletter every week, but it's a deep first newsletter. Sometimes I forget or I don't have time, but usually this is once a week. And I will share today or tomorrow the recording and the presentation and everything through that directly. So you just have to do that. That will make it easier for me, and I think for you as well. Could you recommend some, Francisco, could you recommend some Python library to compute Gaussian splatting? Yes, I can recommend some Python library to compute Gaussian splatting. So maybe you can start with the one from GraphDeco INRIA, which was one of the first one. This is the best one to get started and to have something working. It's not designed to be super simple, but there are really great guys in the community. So Jonathan Stevens, which is I think an influencer, he worked for a company. I don't want to say mistakes, but it was before that it was combining LiDAR and photogrammetry and creating a side point or something like this. But now he made it a mission to try and explore 3D Gaussian splatting, and he's doing a great job at it. And he made a step-by-step instruction on how to set that up. So I could replicate it, but I think it's pretty nice what he did. So maybe can I share that? It's not really, yeah. This will be the link that I will propose to get started with it. Awesome. What else do we have? Do you have recommendation to enhance the pre-processing phase on custom data? Call map is sometimes even random camera poses. Yeah. Yes, I agree. Call map is very good because it's open, but it's not default free. My first recommendation would be trying to add more features and to be a bit more constrained about the feature extractor that you used. Not only sift, but sift, surf, and orb would be good. And if this does not work for you, what you can do is, of course, play on the acquisition phase. Make sure that your acquisition is well organized for a photogrammetric process. If not, you move on to Mushroom and reality capture or reality capture, and you export the post image. Okay, you can do that in both, and you use that directly within PostShot or any other Gaussian splatting software or within Python. That map that you've shown us through this rendering has a good accuracy or not? Can it be used for object detection application? So yeah, it has a perfect accuracy. So it's not direct ray tracing, right? It's another way to represent with this differentiable renderer, but still you could extract or build something that will extract various point of view with the depth estimation and use that as part as object detection pipeline. But today, if you have the 3D side of things directly, I will recommend to use the 3D object to do 3D object detection, except if you have working models that works well with depth images. In this case, yeah, that will be relevant. And that's it for this session on 3D Gaussian splatting. Now you have a very simple way to create these entities, to play around with it. And let's regroup in the next event to push what we can do with Gaussian splatting. It's definitely super useful and super exciting to see how we can turn images and video into these beautiful web experiences. Have a great day. Bye-bye.